I welcome you all to the course on engineering mechanics. In today's video, we are solving a problem on friction, that is sliding friction. The question of the problem is displayed over the screen. A body of weight 100 Newton is placed on a rough horizontal plane. Determine the coefficient of friction, that is mu, if a horizontal pull of 20 Newton is placed on the body. Today we are seeing a problem on sliding friction. So in this problem, they are given a weight of 100 Newton. It is placed over an horizontal rough surface. So from the word horizontal rough surface means there will be existing a frictional force. So that frictional force is now also a sliding frictional force. So what do you mean by sliding frictional force? Whenever a body, that is, like we take this body to be as A. This body is going to slide over the another surface. There exists a force of friction. Force of friction which will be always tangential to the surface. So that will be a frictional force will be acting. That frictional force will also act opposite to the direction of applied force. In this problem, they are given a force of 20 Newton, that is horizontal pull. When the pull is going to be in this direction, the frictional force will be in the opposite direction. We know that from earlier formula, we know that frictional force is equal to mu times of a normal reaction. Okay. So, and then they are also said a weight of 100 Newton is acting over the body. So 100 Newton will be acting exactly towards the downward direction, and then our normal force will be acting perpendicular towards the body. So that will be a normal reaction. Okay. And then, so resolving all the forces in horizontal direction, that is your summation f of x is equal to 0, we are going to take. So we are going to take the force, the pulling force in this positive x-axis direction. So P minus the frictional force, that is horizontal force, frictional force is equal to 0. So P is 20 minus mu times of n, which is equal to 0. This is going to be our equation number 1. Or we also can be able to take 20 is equal to mu times of n. Okay. And then that are given. So we are going to move on to resolving the vertical forces, that is taking summation of f of y is equal to 0. We are having two forces, that is your weight that is acting in the downward direction minus w plus normal reaction is equal to 0. The problem they are given, the weight of the body is is given to be as 100 Newton. So plus n is equal to 0. So we will be getting n is equal to 100. So substituting the value of n, that is 2 in equation number 1, we will be getting 20 is equal to mu times of 100. So mu is equal to 20 divided by 100. You tends to get the value mu is equal to 0.2.